All right, on example 6, we got another limit that we're trying to evaluate, and we're talking about L'Hopital's rule, which requires the indeterminate forms that we know so far, 0 over 0, or some kind of infinity over infinity. Let's see what happens in this example. So if I do a direct substitution here, e to the negative infinity, that's going to be 0, and the square root of infinity is infinity. Basically, I have 0 times infinity. What is 0 times infinity? The answer is, I don't even know. This is another indeterminate form where you're going, hey, it's 0, and you're multiplying it times a really big number. It should be 0, right? Wrong. And the reason why is because infinity, first of all, not a number. And also these things are functions. Each one of these things are functions. It's just getting really, really small, and this one's getting really, really big. It's not actually 0. It's not actually infinity. So this is an indeterminate form. However, you can't use L'Hopital's rule on it because it's not 0 over 0 or infinity over infinity. Or can you? Well, you can if you trick it. And the way that you can trick it is the fact that this e to the negative x, we can make that a positive exponent if we just bring that down to the bottom. I can make it look like this. And then whenever I make it look like that, I plug in an infinity. Now I have infinity over infinity, and you can use L'Hopital's rule on it. Yes. Okay, so here's the idea. When you get another indeterminate form, like 0 times infinity, you turn it into a quotient, and that quotient is either going to be a 0 over 0 or an infinity over infinity. It just depends on which one you put down there at the bottom. So let's go ahead and work this one out. Uh, there we go. So I'm recognizing this as being the indeterminate form, the new indeterminate form of 0 times infinity, which is not L'Hopitalable. That's a word I invented. So I'm going to just rewrite the function as the limit x goes to infinity of the square root of x over e to the x. And now I can see that I have infinity over infinity, which is a check for L'Hopital's rule. So let's now take the derivatives of the top and the bottom. Remember, this is x to the 1/2 power up here. So this is the limit. So x goes to infinity of leapfrog, x to the negative 1/2, and then the derivative of the bottom, of course, is just an e to the x. All right, let's fix all this because it looks ugly. It looks super ugly. Its mom won't even call it. It looks so ugly. So the 2 is going to go on the bottom. The square root of x is going to go on the bottom. I only have 1 on top. 2 square root of x e to the x. Okay, so now let's do a direct substitution. I go, let's see, 1's on the bottom, top I mean, and then on the bottom here we get a 2 times square root of infinity, still infinity, e to the infinity is infinity. This is super big infinity. I got 1 over infinity. Let's get rid of this and then make that thing equal to 0. 1 divided by an increasingly large number is getting close to 0. Okay, so yeah, in this particular case, we had 0 times infinity, and it turned out to be 0. That's not always going to be the case. I want you to think of this as kind of like a race. This function here is racing towards infinity. This function here is racing towards, did I say infinity? This one's racing towards 0. Come on. This second function, square root of x, is racing towards infinity, and we want to know which one of these is going to win the race. Another way to think of this is as like a tug of war, right? We've got 0 on one side, we've got infinity on the other side. Who's pulling harder? Who's running faster towards either 0 or towards infinity? And we can solve it. See that e to the negative x, it was winning, right? It's exponential. Of course it's going to win. And so it won the tug of war, the numerical tug of war. So here is our next indeterminate form. We said that we can only use L'Hopital's rule if we have 0 over 0 or infinity over infinity. Anything else, any other indeterminate forms, of which there are a few more that we're going to learn, you have to trick it. So here is our first one. If the limit as x approaches a of f of x times g of x produces the indeterminate form 0 times infinity, this is indeterminate product, then you try to rewrite it as a quotient by plugging, or not plugging, but just bringing 1 down to the bottom. You may have to take a reciprocal or something like that. The one that we had was very easy because it had a negative exponent, so it could just easily go down to the bottom. That's not always going to be the case. You have f times g can be rewritten as f over 1 divided by g, right? Or g over 1 divided by f. One of these would give you a 0 over 0, and the other one would give you infinity over infinity. Which one you pick, just kind of a case by case, which one is going to be easier for that particular example.